Hello and welcome to this solution video of paper 53 of A-level Mathematics Probability and Statistics 1 Winter 2024. If you really like this video, please give it a thumbs up, share this video with your friends and subscribe to Math United. Let's get started with question number 1. Question number 1 says that 30% of the residents of Winfield own an electric car. Okay, 3 residents are chosen at random. Find the probability that either all 3 own an electric car or none of them owns an electric car. That's straightforward, too easy. Yeah, just 2 marks. Okay, so we can say that the probability of success of getting a person having an electric car is 0.3 because 30% of them own the cars, and probability that none of them or the person does not have an electric car is 0.7. So they're asking us to find the probability either all 3 own electric car. That means 0.3 times 0.3 times 0.3, all 3 of them. 3 are chosen, all 3 are having electric cars. So it's first and second and third having electric cars. So whenever we say and, we multiply. But or, they're saying either this will happen or all 3 don't have electric cars. So not electric car, not having electric car, not having electric car. This will be another option. So just put this carefully in your calculator and you get your answer. What I'm getting in mine is 0.370. I can write 3 single figures. Okay. B part. A random sample of 125 residents of Winfield is selected. 125. Okay. So very big number. Earlier it was 3. Now 125 of them. Use a suitable approximation, and the only approximation which we know in A level is normal approximation. Okay. Find the probability that more than 45 of them, these residents own an electric car, more than 45. Okay. So since we're doing normal approximation, we should first have a test that NP should be greater than 5 and NQ should also be greater than 5. So NP, N is number of selections, 125, multiplied by the probability of success owning a car is 0.3. So that will be how much? 37.5. Obviously, if it is more than 5, multiplying with 0.7 will also be more than 5. So both the tests are done. We can go ahead with normal approximation. For normal approximation, we should first draw a probability distribution table, normal probability distribution, a graph rather, and we should indicate the mean. Mean is NP. Okay, NP was 125 times 0.3, 37.5. So 37.5 is the mean. Now we need standard deviation also. So standard deviation is square root of variance, which is NPQ. So it becomes 0.3 times 0.7 times 125. NPQ. Okay, let's see how much that is. It comes out to be 5.12347. So I'll take 1235. Okay, so I will write 5.1235. I'll use this one as standard deviation. Okay, now they want more than 45. In approximation, we use approximation for discrete data, and this 45 is discrete. So since we want more than 45, that means 45 is not included. So we will write here 45.5. In that case, this will be needed, this probability, this area, and 45.5 and more does not include 45. So this will be our X. They want us to find x is greater than 45.5, which obviously includes 46 onwards. And that's what they want us to find. First, we should find z score for x is greater than 4.45.5. Okay, and that will be the data itself, 45.5 minus mean, which is 37.5, divided by standard deviation, which is 5.1235, which comes out to be 8 divided by 5.1235. That's the z score. So once I'll convert this to decimal, I need a table for that. And here is the table where we want a data that says 8 divided by 5.1235, which is approximately 1.5614. So I think 1.5614. No, this 5614, which will be 1.561 we can use in the table itself. So let me look at the table once more. Here 1.5614. 1.5 is z here, 1.5, then 6 is this, 9, 0.9406. Okay, and then we have to write 1 after that. So 1.51, 1 is 1. So it will be 0.9407. So 0.9407 is lower than 45.5, this one, 0.9407. So this one is greater than, not less than. We don't want less than. So we want this greater area. So we'll total sum of the probabilities is 1. So we'll subtract this from 1. 9407 will be subtracted from 1 and we get 0.0593, and this will be the probability. They are asking probability. So this is the probability to 3 significant figures that the residents, 45, more than 45 of these residents own an electric car. Question number 2. A red fair 6-sided dice has faces 1, 1, 1, 2, 2, 2. Okay, so 6 faces are labeled as these numbers. A blue fair 6 dice sided dice has face labeled these. Both dice are thrown. The random variable x is product of the scores on the 2 dice. Drop the probability distribution. So whenever we have 2 dice, we should always make a table with all the probabilities, right? So since they are fair, so I will do what? I will write them separate. The numbers which are coming out are written separate. So 1, 1, 1, 2, 2, 2. This is the first dice, this one. Second will be this way, and that I will write as 1, 1, 2, 2, 3, 3. 1, 1, 2, 2, 3, 3. I could have combined them also because their repetition will be giving their probabilities, but I'm not doing that. So that's it. I'm writing the final answer with these outcomes. So 1 multiplied by 1, this is a product, right? The random variable x is the product of the score. So I'll multiply this one and this one. I get 1, 1, 1, 2, 2. Again 1, 1, 1, 2, 2, 2. And 2 multiplies with 1 gives us 2, 2, 2. And this 2 multiplies with 2 gives us 4. Similarly, 2, 2, 2, 4, 4, 4. And 3 times 1 is 3. So 3, 3, 3. 6, 6, 6. 3, 3, 3, 6, 6, 6. And now we know that our outcomes, they're saying draw up a probability distribution table, and probability distribution table will be drawn for only these white colored numbers. So let me write this way. X is here and the lowest number possible is 1. So we have 2 and 3 and then we have 4, but there is no 5. Okay, 6. Okay, now total 6 times 6, there are 36 cells. Can you see how many of those 36? Let me write here the simpler form. I will write up there, but let me count how many 30 out of 36. How many are ones? 1, 2, 3, 4, 5, 6 out of 36. Okay, how many are 2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 1, 2, 3, 4, 5, 6. Okay. 4 is there also 6. And then we have 6 out of 36. How that's that simple. Okay, this is what it is. So simpler form of 6 over 36 will be 1 over 6. This will be 1 over 3, 1 over 6, 1 over 6 and 1 over 6. Okay, you can convert them to decimals also, but this looks cleaner. This part becomes our main table, probability distribution table. Okay, next part says find the expected value of x. And to find the expected value of x, we need to use this formula. Sigma of every x multiplied with its probability. This one is that probability that x is equal to capital X. Okay, that's it. We need to just multiply and add them. So multiply each data 1 with 1/6 plus, because of sigma, 2 with 1/3. Then we have 3 times 1/6, 4 times 1/6, okay, and 6 times 1/6. Since there are 4 of them who have 1/6, so we can just take common 1/6 out of them. So 1 plus 3 plus 4 plus 6. How much is that? 4 plus 4 is 8 plus 6, 14 plus 2/3. This one is the only one which has a probability of 1/3. So 14 over 6, and that comes out to be 14 plus 4, 18 over 6, or 3. 3 is the expected score of this particular data. So done both parts. Question number 3. In Molimba, the heights in centimeter of adult males are normally distributed with the mean of 176. Normal distribution 176. So let's try to visualize this. Mean is always at the center, 176 centimeters. And standard deviation is also given for 0.8. Find the probability that a randomly chosen adult male, is it adult male? Yes. In Molimba has a height greater than 170. So 170 will be little lesser than 176. And this is what we need to find, the greater than 170, which is difficult with the table we use in exams. So table will give us something else. So I'll explain how to do this, because we want greater than, and this is a negative Z score. Let me show you the formula sheet, which is there is no negative Z score in this. So what will we do? We will find its opposite. There is a difference of 6 here. Can you see? So we'll go to 182 basically, 6 more. Because normal distribution graph is uniform, we'll find the Z score for 182. And then they want us to have 170 or greater. So 182 and lesser will be the same, because 170 and 182 are reflection of each other. So if I find less than 182, It is exactly same, which is greater than 170, this one. So basically I'm going to do 182, though I will not mention 182 anywhere. I'm just trying to make it understandable to you. So I will use 170 only, but I will get a negative z-score, which I'll turn it to positive, which will belong to 182. Okay, so let's find the z-score first for x less than 170. For that, we write the data we have 170 minus mean divided by standard deviation, which is 4.8 in this case. And can you see 170 minus 176 is negative. We'll get a negative z-score, but we'll convert it to positive, and which will become for z-score for 182. So minus 6 over 4.8, 1.25. So minus 1.25 is the z-score. But since it is 182 less than that is giving us the same answer, we'll use positive z-score in this. So z-score of not z-score, probability now. Probability that z is less than 1.25, positive 1.25, is same as probability z is greater than minus 1.25, which is our requirement, this one. So I'll just find this with the help of the table, and that will be my answer. So let me go to the table again. 1.25 is what I need to know. Z-score 1.2 is here and 5 is here. 8944, 0.8944 is the one, because we don't have any other digits, so we don't need to add anything else. 0.8944. So probability of z greater than minus 1.25, or probability of x greater than 170. Yeah, it was less than 170. We wanted greater than 170 is 0.8944, and I'm ignoring the fourth digit because we need 3 significant figures. Going to question number 6b, not 3b. Okay. It says the 60% of adult males in Molimba. So that one is, so they are talking about the same adult males, Molimba. So they're talking about the same situation. It is not a different one. Okay. So 60% of adult males in Molimba have a height of between 170 and k centimeters. So what was the mean? Mean was 176. Okay. So 176 is mean, 170 is here, and k could be less where k is greater than 170. Okay. So suppose k is here above 170. I'm just assuming. Okay. K. And this area between these two is 60%. 0.6 is the probability in this area. Okay. Find the value of k, giving your answer correct to one decimal place. So everything is same. So we don't have to worry about this. So 170 and greater, we already know, right? So somehow if we find k and greater, this one, and subtract from the one we got earlier, what was that? That was 0.894. This from here to here was 0.894. From here to here is 0.6, and up to here is 0.894. So 0.8944 was the number, right? Minus 0.6 will be 0.2944. This area, this probability sum is 0.2944. That's what we conclude from here. Okay, but the table I'm talking about is always less than. This table is always less than a number, not more than. So this 2944 has to be converted to less than. So probability that x is less than k is 1 minus 0.2944. 0.44, and which comes out to be how much? 0.7056. That's the probability, right? Now we'll have to go to our table again and see what Z score is corresponding to this. So Z score corresponding to probability equal to 0.7056. What is Z score corresponding to this? That's what we need to know. And then we'll proceed. So let me go to the table again. 0.7056. 7054 is here. 0.54. Okay, and then we need 2 more. And we don't have 2, we have just 3. But 2 is closer to 3, so I'll say 1. 0.541. Yeah, 0.541 is Z score. So 0.541 is Z score. This Z score 0.541 will be used with the formula for Z score which we used here. The value minus the mean divided by standard deviation. So this is what I can do here. Value we don't know, it is K, minus mean we know 176 divided by 4.8. So I'll cross multiply this one first. So 0.541 multiplied by 4.8, and then 176 go there, plus 176 will be the value of K. Let me find this out. By the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting for K is 178.5968. So I will make it 3 second figures by 178.6 centimeters. That's the value of K. Question number 4. On a certain day, the heights of 150 sunflower plants grown by children at a local school are measured this way, and they have given a grouped data. Draw a cumulative frequency graph to illustrate the data. And there are 2 things we need to do in this data. First of all, we should close this gap. This is 19, this is 20, this is 29, this is 30. So we should always close the gap to make it a continuous cumulative frequency table. So what will we do? We can add, what is the difference between 19 and 20? 1 divided by 2. So 0.5 is the half of that, right? So add 0.5 to the lower, upper limit of every group and subtract 0.5 from the lower one. So this becomes 9.5 till 19.5. This becomes 19.5 till 29.5 and so on. Okay, so this is how we close the gap, and our cumulative graph will be straight without gaps. The graph will be without gaps. Second thing we need to do is to add all the frequencies, and this frequency we have to make at cumulative frequency. And how do we do that? We just add the previous sum to the next one. So just like 10 will be added to 18. So 10 remains 10, but next one will become 28. What it means that 28 sunflowers were less than 29.5 centimeters high. Okay. Now 28 will add to 32, becomes 60. 60 plus 42 becomes 102, 130, 144, and 150. This was the total number of sunflowers which were observed on that day. Okay, and now we need to draw a cumulative frequency graph with this data, new data 10, 20, 60, with the upper limit 19.5, 29.5, and so on. So that's what I'm going to do. The first point I will have will be 19.5, the upper limit with the frequency. So it means that 19.5 will be less than this, right? And it has a reading of 10. So 20 is this one, little less than that will be 19.5 here. It means 10 sunflowers, not here, little lower. 10 sunflowers are less than 19.5, 10 of them. That's what it means. Okay, and I will just complete this whole graph and then talk to you. So I've tried to be as accurate as possible. I've joined them by straight lines so that I get my answer in the best possible way. All right, so this is the cumulative frequency. We need to label, always we should label this is cumulative frequency, and this horizontal coordinate is height in centimeters. Okay, now the second part says use your graph to estimate 30th percentile of heights of the sunflower plants. 30th percentiles means find 30% of total numbers. So this is 2, this is 3, 15 times 3 is 45. So 45th data will have 30th percentile. So 45th is here, and let's go to the line where it is 45th here, and let's see where it is being matched here on the horizontal, exactly at 35. So 30th percentile is 35 centimeters approximately. Some people can get a little bit here and there. In marking scheme, they will always give you a range within which your answer should be. Okay, see, calculate estimates for mean and standard deviation of the heights of the 150 sunflower plants, and then we'll have to do something new. So let me copy this part. Okay, so I have copied the table here, and now I will do the first thing. I will find the mean first. So for mean, I will make a new table with new limits which I decided earlier, 9.5 to 19.5 and so on. Next thing, I will find out their mean. Mean means mean of two limits of the same group. So 9.5 plus 19.5 will be 29 divided by 2 will be our mid value. We call it mid value. Let me call it x. Okay, so 14.5 is the mean of 9.5 and 19.5. Similarly, I'll find for all of them also. Okay, found that. Now next thing is that we multiply each x with its frequency. And what is the frequency? These are the frequencies, 10, 18, 32. That's what we'll do here. So 14.5 multiplied by 10, the first one. So it will be 145 and so on. So what I've done, I have multiplied each mid value with its frequency. That's what we got. And because the formula for mean is sigma x f over sigma f, I added, because of this sigma, I added each multiplication of the data mid value with its frequency, and I added them. I got 5840. And the sum of all the frequencies is 150, which is given to us already in previous part. Also in cumulative frequency found it. So if I divide this, I'm getting 38.9333. So 38.9 centimeter is the mean height of sunflower plants. Second part says standard deviation. For standard deviation, I'll again make some more space, and once I'm done, I will explain it to you. Alright, so I did this. What I did, I squared each x and I got x squared for them. Then each x was multiplied by their relative frequency, which was given here. Just like I did xf, I did x square f also. And now the formula for standard deviation is square root sigma x square f divided by sigma f minus mean square. And mean is already known to us. I just Substitute the values here, which will be 244, 285. I added all of them. This is what sigma x square f is. Divided by numbers, they were 150 minus 38.9 square. Carefully put this in your calculator and you get your standard deviation. By the time I do this, I would request you to like this video, share with your friends and subscribe to Math United. What I'm getting with my calculator is 10.6 is the standard deviation. Question 5. A factory produces chocolates. 30% of the chocolates are wrapped in gold. So probability of gold wrapped chocolates is 0.3. 25% are wrapped in red foil. Probability in red foil is 0.25. Okay, and remainder are unwrapped. So probability of unwrapped will be 1 minus 0.3 plus 0.25, which is 0.45. This is our basic knowledge. Okay. Indigo chooses 8 chocolates at random from the production line. 8 chocolates at random, so fixed number of chocolates. Okay. Find the probability that she obtains no more than 2 chocolates. No more than 2 means what? It means either 0 or 1 or 2, but not more than that. That means these are the 3 options. Alright. Wrapped in red foil. So our probability of success, P, is red foil, which is 0.25. That means the probability of failure is 1 minus 0.25, which is 0.75. Now we need to interpret them into binomial probability distribution, because number of selections are fixed, the probability is constant, and they are independent choices. So we'll use binomial probability distribution. For 0, probability of x equal to 0, let's write. The number of successes are 0 will be NCR. N is total number of selections, 8. CR, successes are 0. And probability of success is 0.25. Its power will be 0. And 0.75. All 8 are failures. Alright. Or, that means plus. It will be x is equal to 1. The second case, which will be 8C1, 0.25 to the power 1, and failure are 7 of them. Sum of these two should also always be equal to the total number of selections, and then Px equal to 2 will be 8C2, 2 successes, and then 0.75 to the power 6. These many failures, and because either this will happen or this or this, all 3 cannot happen together, or any 2 cannot happen together. So we will just find these probabilities one by one and add them and find the answer. What I'm getting is 0.679. 3 significant figures. B. Jake chooses chocolates one at a time. Okay, so from the production line, find the probability that the first time he obtains a chocolate that is wrapped in red foil. So red foil is your success. Probability will be 0.25 again. Then failure will be 0.75. And we want first time. That means it's a geometric probability, because he will fail before the first time he gets a chocolate before seventh choice. Before seventh choice means sixth. How can we interpret this sentence is that she, or Jake is a boy, so he does not fail in all six choices. So first six choices he does not fail in all of them, right? He gets success somewhere in between. So what we'll write, 1 minus he fails in 6, 7, 5. 6 times he fails in a row is not there, so 1 minus that probability will give us the answer. What I'm getting here is 0.8223 significant figures. Okay. Next, Kaifa chooses chocolates one at a time at random from the production line. So this different person, Jake and Kaifa. Okay. Find the probability that the second chocolate chosen is the first one wrapped in gold. That means the one before it can be red or unwrapped. Okay. Given that the fifth chocolate chosen is the first unwrapped chocolate. Okay, this kind of question has come for the first time, so we will have to define our events. So let's say that the event A is this one, the first one wrapped in gold. The first gold wrapped is in second chocolate, right? That means before that we get something else. So it will be, we'll get something else. That means we get gold. Gold was 0.3, right? Gold foil 0.3. Yeah, 0.3 is the gold one, and before that we get something which is not gold. Okay, this is the probability. The first gold wrapped is this. So, sorry, the second chocolate chosen is the first one wrapped in gold. Okay, this is the one. Given that B is fifth chocolate is the first one, fifth chocolate is first unwrapped. That means there will be 4 something else and the fifth one will be unwrapped, which was 0.45. That means 0.55 will be the first 4 ones. Okay, I'm just trying to understand this. Okay, so probability of A given B is always probability of A intersection B divided by probability of B. So probability of B is known to us, so there's no problem in that. We can straight away write this. So 0.55 to the power 4 times 0.45. Okay, now A and B should have common thing. That means in this, out of this one, we have to take the case where the second is gold but the first one is not gold. Okay, so second is gold with 0.3. The first one is not gold, but problem is they have also said the fifth should be the first unwrapped, fifth. That means out of this 0.7 we have to remove this 0.55. That means only red wrapper should be the first one. So this is first, this is second, and then we have fifth, which is 0.45. Third and fourth can be a red or gold. They've said we have to make sure that the fifth one is this unwrapped, but before that it can be anything. But these two cases has to be there because it's an intersection. We have to make sure that both the conditions happen. So this thing will not happen. This will change to this one, and now the third and fourth will be anything but unwrapped. So 0.455 we can write, which we wrote 4 here. So this can cancel with this. This will become 2 and these two will cancel out. So our answer will be this: 0.2 times 0.3, 0.075 divided by 0.5 square, which will be 0.3025. Okay, let's see what do we get. What I am getting is 0.247933, so I can write 0.248. 3 significant figures. Question number 6. Find the number of different arrangements of 9 letters of happiness. Happiness. That's it? Okay. So 9 factorial ways different letters of any word can be rearranged, but we need to divide it by the ones which are repeating. P is repeating here, S is repeating, so 2 of them are repeating. So 2 factorial divided by 2 factorial. This will be the number of arrangements, which comes out to be 90,720 arrangements. Okay, now the B part says find the number of different arrangements in the word happiness in which the first and the last letters are not the same as each other. They are not same as each other. Okay, so these are the total number of arrangements. So let's do that. We'll get the cases then when first and last are same. So suppose first is P of happiness and the last one is also P. So there are 7 of them, 1 2 3 4 5 6 7 between them, right? We don't want these cases. Again, we don't want S1, S 1 2 3 4 5 6 7 and S. We don't want these two cases, but we will calculate them first and then we'll subtract it from the total number. So in this case, even P's change their places, there's no change. So they are fixed here. 7 factorial ways. The remaining 7 can be rearranged. But among these 7, there are 2 S's. So we have to divide by 2. Similarly, here in case of S also, it will be 7 factorial divided by 2 factorial. So if I add these two, they become 2 times 7 factorial over 2 factorial. Actually 2 factorial is 2, so we can cancel. Just 7 factorial. So from total 90,720, if we subtract 7 factorials, okay, because these two cases we don't want. That's it. First and the last are not the same as each other because others are not repeating, so we can't have in other cases. So only these two cases. So this is what we should find out. By the time I use my calculator for this, I'll request you to like this video, share with your friends, and subscribe to Math United. It will motivate me to make many more videos like this. Okay, what I'm getting here is 85,680 arrangements. Alright, let's move on to another part, which is C part. It says find the number of different arrangements of 9 letters of the same letter happiness, words happiness, in which the 2 P's are together and there are exactly 2 letters between 2 S's. In this case, we can think of 2 situations because they said exactly 2 letters have to be between S, 2 S's, right? So there can be S, P, P, S. This case can be there, right? Or S, some other number and S. There can be 2 situations like this. So let's see this situation first, how many ways this can happen. So 4 of them are there. So 1, 2, 3, 4, 5. and we want this situation to occur every time in this case. So we'll make a box around these 4 and they will move in these places. 1 is already there, so 2, 3, 4, 5, 6. 6 factorial ways this particular arrangement can be done. But this one will be a little different because P and P has to be together, so we'll put them in a box like we did these 4 here, right? There will be something else between S, and then there will be 3 more. So that makes 9 alphabets. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright? So we cannot have P's between S's in this case, so we'll select these 2 numbers first. So we'll have 5C2. Out of these 5, we'll choose any 2 which will be between S's. Then those 2 numbers chosen can be rearranged with each other. They can interchange their places and it becomes a different arrangement. Right? Now, this P can change its place with these 3 only. It can't come in between S and S, otherwise it will become 3 alphabets between S's. So 1, 2, 3 and 4. There will be 4 factorial ways in which PP can change its place with these 3, which were left out from this arrangement, the one we did earlier. And finally, look at this. This S and with 2 numbers in between can go to this place, which is second, this third and fourth. And this S can take place of P also, isn't it? This is how these 2 remain between S's, and these S's can take 5 places in the whole arrangement. So we'll have to multiply this by 5 also. So let's see how much this comes out to be. First I will find out what is 6 factorial, which is 720. Okay, and then 5C2, 4 factorial, 2, 5 is 2400. And now you can add these 2, which gives us 3120 arrangements total. This is the final answer. Let's see if we have another part. Yes, we have D part also. The 9 letters of the word happiness are divided at random into a group of 5 and a 4. Okay. Find the probability that both P's are in one group and both S's are in other group. Alright. So group of 5 and 4. It can have a reverse also. So 5 and 4 we can say, and 4 and 5. So PP are here, SS are here, PPs are in this group of 4 and SS. This happens or that happens, right? So now we want a group of 5 here. So PPs are already here. We need to select 5, remaining 5, right? Because S's are here. So we have to select 5C3 in this case, right? And then we have to select remaining 2C2, which is 1. So there's no point of this. So 5C2 is 3 is in this case. And here will be 5C2 and then 3C3, which is 1 again. So there is no point. So it will be 5C3 plus 5C2, which will be 10 and 10. 20 groups. This is the number of, okay, sorry, they are asking probability. So we'll have to find probability. That means the probability of this one will be divided by total 9C. We are selecting how many? 5. And here also 9C5. Remaining 4 will be there. So we don't need to write times 4C4. We can write times 4C4, but there's no point of doing that. So this is not what we need to finish. It will be 10 divided by 9C5. 9C5. 126. So 126 plus 10 over 126, which becomes 20 over 126, and that becomes 10 over 63. 10 over 63, or you can divide, you can convert this into decimals also. So let me write 10 over 63 is 0.1587, so 0.159. This is the probability, not arrangement, for this thing.